there are two questions given here, but in exam you can choose either question A or question B. Let us start with question A first. Here the question is, show that the following lines do not intersect each other. And we have two lines. Now let us find the quadrant of any point on the first line. Here the line is x minus 1 by 3, which is equal to y plus 1 by 2, which is equal to z minus 1 by 5. Now we are going to find the coordinate of any point on this line, which is equal to lambda. So if we find this x equal to 3 lambda plus 1 and y equal to 2 lambda minus 1 and z equal to 5 lambda plus 1. Now the coordinate of a general point on the first line is 3 lambda plus 1, 2 lambda minus 1, 5 lambda plus 1. Now we are going to take the second line and we are going to find the coordinate of any point on the second line, x plus 2 divided by 4, which is equal to y minus 1 by 3 equals to z plus 1 by minus 2, which is equal to mu. Now we have x equal to 4 mu minus 2, y equal to 3 mu plus 1, z equal to minus 2 mu minus 1. Therefore, the coordinate of a general point on the second line are 4 mu minus 2, 3 mu plus 1, minus 2 mu minus 1. Now we know that if the lines intersect, then they have a common point. So for some value of lambda and mu, we must have 3 lambda plus 1, which is equal to 4 mu minus 2, and 2 lambda minus 1, which is equal to 3 mu plus 1, and 5 lambda plus 1, which is equal to minus 2 mu minus 1. Now we are going to write 3 lambda minus 4 mu, which is equal to minus 3. So this is 1. And the second one, 2 lambda minus 3 mu, which is equal to 2. So this is equation number 2. And the third one, 5 lambda plus 2 mu, which is equal to minus 2. This is equation number 3. Now we are going to solve 1 and 2 to get the value of lambda and mu. So for that, we are going to multiply equation number 1 by 2. If you multiply, we get 6 lambda minus 8 mu, which is equal to minus 6. And we are going to multiply equation number 2 by 3. We get 6 lambda minus 9 mu, which is equal to 6. If we change the signs, we get minus, plus, minus. So we can cancel out this one. So we get 9 minus 8 mu, we get mu, which is equal to minus 12. Now we are going to substitute the value of mu in equation number 1. We substitute, we get 3 lambda minus 4 times over minus 12, which is equal to minus 3. And 3 lambda plus 48, which is equal to minus 3. So 3 lambda equal to minus 51 and lambda equal to minus 17. Now we are going to substitute the value of mu and lambda in equation 1. So if we substitute, we get 3. Now we are going to substitute the value of mu and lambda in equation number 3. So the equation is 5 lambda plus 2 mu, which is equal to minus 2. So if we substitute the value of lambda here, we get minus 17 plus 2 into mu is minus 12. So now we check. My 5 into minus 17 is minus 85 minus 24. So we get minus 109, which is not equal to minus 2. Which means here LHS, which is not equal to RHS. So we can say that the given lines are do not intersect. Given lines are do not intersect each other. So intersection points does not exist for this one. Now let us see the mark distribution. For writing the value of coordinate points, you get 1 mark. And from the second line, writing the quadratic points, you get another 1 mark. And filling the equation and substituting the value of mu and lambda, you get 2 marks. And substituting the value of mu and lambda, checking whether LHS and RHS are equal or not. And finally finding the answer whether the lines are intersect or not, you will get another 1 mark. So totally 5 marks for the given question. Now let us solve question B. Here the question is find the angle between the lines 2x equal to 3y equal to minus z and 6x equal to minus y equal to minus 4z. Now we are going to write the direction or ratios of a line to x minus 3y which is equal to minus z, which can be written as x by 1 by 2 which is equal to y by 1 by 3 which is equal to z by minus 1. So we can write it as the direction ratios 1 by 2, 1 by 3, minus 1. And the direction ratio for line 6x equal to minus y, which is equal to minus 4z, which can be written as x by 1 by 6, which is equal to y by minus 1, which is equal to z by minus 1 by 4. So now the direction ratios are 1 by 6, minus 1, minus 1 by 4. Now direction cosines. Direction cosine of both the lines are, you can try 1 by 2, 1 by 3, minus 1 and 1 by 6, minus 1, minus 1 by 4. Now getting the value L1, M1, N1 and L2, M2, N2. Just we are going to multiply the first points with the direction ratios with 6 and the second one we are going to multiply by 12. So if we multiply we get L1, M1, N1 which is equal to 3, 2, minus 6. And the second thing L2, L2, N2 which is equal to 2, minus 12, minus 3. So we have multiplied these points by 6 and these 1 by 6 minus 1, minus 1 by 4 by 12. Now we are going to find the direction cosine cos theta which is equal to L1 into L2 plus M1 into M2 plus N1 into N2. So if you multiply this we get 3 times of 2 plus 2 times of minus 12 plus minus 6 times of minus 3. So we have 3 2s are 6, minus 2 12s are 24, so plus 18. So if we add this we get 0. So we have cos theta. We have cos theta which is equal to cos 90 degree. So the angle theta is just nothing but 90 degree. So now the question is find the angle between the given two lines. So the angle between the given two lines is 90 degree. Now let us see the mark distribution. For finding the direction ratio from first line we get 1 mark, and finding the direction ratio from the second line we get another 1 mark, and writing this L1, M1, N1, L2, M2, N2 we get another 1 more mark, and writing the formula finding the angle and substituting the value we get 1 mark. Finally simplifying getting the value of theta you will get 1 more mark. So totally 5 marks for the given question B.